Hello YouTube! Today we're going to do an overview of basically everything that we've covered so far in the first couple of weeks of freshman physics. This is because we're sort of getting a lot of new students, and so just having it all in one place would be good, but also we're having a quiz soon, and so just having a recap would be nice. If you want things to be organized in a PowerPoint or slides, you should look back at the Google Classroom. The slideshows are all posted for everything we've done so far, and things are in a much more sort of verbose and organized way there. Real point here is just to get quick going through everything. We're going to miss some details, but just like all the stuff you really got to know in order to be able to do the stuff that we've learned. So we're just going to start out with some vocab. First off, we've got position. So what your position is it's a way of telling you where you are. But the problem is that where you are is really hard to describe unless you're careful about how you're describing it. If I just tell you that I'm 5 meters away, from what, right? Like that's not actually a location. You're going to need to give a start location for things to begin off of, and that's called the origin. So your origin or your reference point is the first thing that you'll need in order to actually tell someone where something is. So once you have your reference point, let's say in a given room, it would be something like start at that painting. So I guess that would be west. I am 3 meters away from that painting. Now that still doesn't tell you how to get to my exact location right now, but it is a start, and that would be a distance. The last thing that you'll need, though, is a direction, because you have to tell me which way to walk. So like 3 meters west, and suddenly you've given of the painting, and you've given a position where someone can actually get to the location. They have their start point, they have their end point. The one thing about a reference point is it does have to be something that they actually understand, right? If I say the painting, there's a lot of paintings. You would need to make sure that you were communicating which painting in which location and somehow. And once you've done that, you've got a position. Great. So now we know how to say where something is. The next problem comes in if we're trying to describe how something moves. Because let's say I've got a few different objects, and one of them starts, or you got this object that starts here, right? And it goes around all the way to here. And let's say that the dotted line, if we're looking at it, is 20 meters long, but the direct arrow going from the start to the end is 10 meters northwest. What's interesting about this is if you're looking at this and you're trying to figure out, well, did it go 10 meters or did it go 20 meters? It's actually kind of ambiguous. It could be either, right? You could argue that it went the 20 meters because it did actually travel 20 meters along a given path. But you could also argue that it only went 10 meters because it's only 10 meters away from where it started. And this sort of gets into the difference between our next two vocab words. So first up, we've got distance. And distance is how far you actually go. In the picture, the red dotted line would be your distance if you're actually tracing it out. What your displacement is, there's so many different ways to think of this, is the change in your position. Another way to say that is the distance from start to end, or specifically the path from start to end. If you were going like right in a straight line, straight from here to here, going straight there is your displacement. Oh gosh, there are so many other ways to describe it, and I'm kind of blanking on them, so I think I'm just gonna call it there. So in particular, again, your displacement is describing how to get from here to here, from your start point to your end point in a straight line. And so you're going to need to have a direction on it so that people actually go the right way. Because if I just said go 10 meters, that could put them here, that could put them here, that could put them here. None of those are the right spot. We'd need to actually tell them go 10 meters, like if we're being really careful about it, 20 degrees above the x-axis or something like that. So one of the really big differences here is if you look at this red dotted line, there isn't any one specific direction. So when you have your distance, you know how far you've gone, but you have no idea where you wound up, and you have no idea which way you went. When you have your displacement, you actually don't know how far you went to get there, because it's just, well, I started here, I ended here, I don't know anything about the middle, but you do know where you wound up. This first one doesn't require a direction, this second one does. And that sort of means that we have to start keeping track of numbers as though direction matters. And if we're going to do that, we're going to need a couple new vocab words for that. So first off, we've got scalar. For me, the way to remember this one is that it's got the word scale in it. If you think about what scales do, they measure how heavy something is or how large it is, effectively. So a scalar is something that tells you how big something is. And this is literally just any number. So it's the size of something only. And this is just numbers. Anything you've worked with before, like saying 5 apples, like saying 6 feet, saying 30 miles per hour, anything like that is going to be a scalar because, again, it's just telling you how big a thing is. But let's say that we want to tell someone that they need to go 10 meters in a specific direction. We can't just say 10 meters because they won't go to the right place. We have to say 10 meters and then point them in the direction that they go. And that is called a vector. You draw it with an arrow. And it's a number for a size. And it always also have a direction. So if we look back at the things that we've already talked about, your position needs to have a direction. And so because your position needs to have a direction, your position is a vector. If you look at distance, that didn't go in any specific way. It's just all of it all together. So this one is a scalar. If you look at displacement, the direction really matters, so you wind up in the right spot. So this one is a vector. As one last little piece of vocab, the number part of a vector, is magnitude. Like the magnitude of an earthquake telling you how big an earthquake is, the magnitude of a vector is just how big the vector is. So if I were to tell you 10 meters north, that's a vector because I added the word north. The magnitude of 10 meters north is 10 meters. Great. So that's how we describe the motion that actually happened. That's how we describe where we are. But what if we want to talk about how we're moving right now? This is where speed and velocity come in. So speed is a little bit more straightforward. It's just how fast you're going. If you think about what that actually means, if I tell you that I'm going 65 miles per hour, what that's actually telling you is that if I wait 1 hour, I will have traveled 65 miles. And that's faster than something like 30 miles per hour, because if I say 30 miles per hour, that means that if I wait 1 hour, I go 30 miles. 30 is a smaller distance in the same amount of time compared to 65. So the 65 miles per hour is faster. So what fast actually means is how many distance units you go each time unit. For this class, mostly how many meters you go each second. Velocity is something that's really close to that, but we can't just, and the reason we're bringing it up and the reason that we have it is because sometimes you don't just care how fast you're going. What if you want to try to make sure you get to the right place or figure out how long it'll take you to get to a specific place? If I'm trying to go from here to here, it'll matter a lot if I'm going in this direction or this direction for how long it'll take me to get there. So I can't just say that I'm going 2 meters every second, because if I'm going 2 meters every second in the wrong way, it's going to be very different. And so that's where the velocity comes in handy. It would help if I spelled the word velocity correctly. All right, great. So what velocity is it's the speed and direction of travel. So what speed tells you is how many meters you'll go each second. The velocity tells you where you'll wind up if you wait a second. And in particular, it's going to say if nothing else changes and you keep going in the line that you're going in, because nothing's making you do anything weird, this is where you'll wind up after 1 second. So if I have 2 meters this way, what that's saying is if you wait 2 meters, you'll be here. If you 1 second, you'll be here. If you wait another 1 second, you'll move 2 meters from there and you'll be here. If you wait another 1 second, you'll move 2 meters from there and you'll be here. Something like that. So speed doesn't care about where you're going. It just says you're going this far. Velocity cares about where you're going. It's saying you're going to here. That should be ringing some bells off of displacement and distance, because distance is just saying this is how far you went, and displacement is saying you went from here to here. It gives you an actual location. Similarly, speed is a scalar. Velocity is a vector. Has a direction, doesn't have a direction. This one's actually pretty easy to remember. S for speed, S for scalar, V for velocity, V for vector. Now, when you're trying to find these things over a given amount of time, so let's say that instead of saying what are we doing right now, like what's our speed at this moment or what's our velocity at this moment, which would be called instantaneous speed or instantaneous velocity, instead, let's say we're trying to figure out roughly what we did over a longer period. More directly, let's say I went from here to here and I know that the whole thing took 5 seconds. Even if I didn't go at a constant speed the whole time, meaning my speed didn't stay the same the whole time, what I could do is figure out how fast I would have had to go at a constant speed and still get the same distance in the same amount of time. That would be my average speed. So your average speed is the speed needed to go the same distance in the same amount of time. With a constant speed. So this one winds up using distance. But if we think about the average velocity, what that one is telling you instead is the velocity, or I'm actually going to save some writing later, the constant velocity you would need to get to the same place in the same amount of time. This one uses displacement as a result. So our equations for these two are that your average speed is equal to the distance you travel divided by the time. So these are speed, which uses units of meters per second, if you see that in a problem. Distance, which uses units of meters. And time, which uses units of seconds. If you want to find velocity, it's that your average velocity is equal to your displacement divided by your time. Displacement is triangle and then x, because triangle means change in. If you see it in math, it's not going to come up too much outside of physics. And x is position. One of the first things we said about displacement is that it's the change in our position. That's why the symbol is change in position. So this is displacement, which is in meters. We've got time, which is seconds, and v, which is velocity. These have the word av after them to say that it's the average one. But if it's a constant velocity or a constant speed, you could just remove the av and this would still be true. Let's do a quick example problem so you can see roughly what types of math you'll be expected to do. You could also have to do something with a little bit of calculus. I'm not really going to do that now for the sake of time because I figure I'm probably going to already be losing people after 15 minutes. But those exist. Ask for help on them if you want it. So let's say I've got a problem where I go 10 meters forward, 8 meters backwards, then let's go with 7 meters backwards in 5 seconds. A, find the distance. B, find our displacement. C, find our average speed. And D, find average velocity. One approach that helps a lot for a lot of physics classes is to just sort of go through and start highlighting things in the problem. If you don't know what variable it goes with or what thing from an equation it goes with, chances are you're probably supposed to use it to draw a picture. So I see that I go 10 meters forward. Something we haven't talked about yet. If you have forward motion, that means it's positive. If you have backwards motion, that means it's negative, just like on a number line. So if we've got 10 meters forward and 8 meters backwards, I would start here. I'd go forward by 10. Draw a little arrow going backwards with a -8 next to it to let me know that I go backwards by 8. Draw a little arrow with a -7 to let me know that I go backwards by 7. To find my displacement, the distance that I've traveled, it's thinking about the definition. We're just saying how far we actually went. Going backwards doesn't mean you aren't going. It just means that you'll be further to the left as I've drawn it. So it doesn't matter if it's plus or minus. It still counts as moving. So we just ignore the pluses. We ignore the minuses. We keep just the number part of it. And we're good. So for our distance for this one, we do plus for our 10. We do plus for our 8. And we do plus for our 7. And when we add all those together, we'll get 25 meters, and that's our distance. For the displacement, though, because displacement needs to tell us where we went, we need to actually care if we go forward or backwards. So we have to keep our plus or our minus. So we'll have plus for our 10, we'll have minus for our 8 because it was backwards, and we'll have minus for our 7 because it was backwards. And when we add all those up, we'll get 10 minus 8, which is 2, minus 7, which is minus 5. Negative is totally fine. It just means you went backwards. 0 is totally fine as well. It means you started where you began. That's always true. You ended where you began. All right. So now let's find our speed. If we're trying to find our speed, this is where this 5 seconds comes in. I'm going to actually just write time is 5 seconds right next to it. So I remember that if I want to use an equation that has t in it, I totally can because I know that the time is 5. To find average speed, all we have to do is do distance divided by time. We know that our distance from part A is this 25. So I can replace d in my equation with a 25. I know that my time from the problem is 5 seconds, so I can replace t on the bottom with 5. When I divide those two, 25 divided by 5 is 5. My units are going to be meters per second because I had meters on top and seconds on bottom. Average. For our next one, it's going to be very similar, but velocity. And that'll be displacement divided by time. We're just taking these two equations. Plugging in our numbers from what we've already found, our displacement was -5. Our time was 5 seconds. So putting those together, we get -1 meter per second. And that's it. So recapping, really go through the problem. If it's backwards, make it negative, draw it to the left. If it's forward, make it positive, draw it to the right. When you're trying to find your distance, you add all of the motion that you do and ignore whether or not it's forward or backwards and just make it all positive. When you're finding displacement, it matters if it's forward or backwards. Add them together and keep the minus if it's backwards. When you're finding speed, make sure you use the equation that actually has speed in it and plug in for your distance, divide that by your time. When you're finding velocity, use the equation that has displacement in it, or velocity, plug in for your displacement, plug in for your time. There are a few other things that could show up on the quiz, 100%. I would say go through the quiz review, look at the answer key, ask questions, but for now, I think that's a good place to stop. So goodbye, YouTube, and I hope you have a great day.